In this video we will learn how to balance redox equations, which are basically a fancy way of saying oxidation reduction reactions. So an oxidation reduction reaction can occur in acidic medium or it can occur in basic medium. So looking at this problem here, part A, we're asked to balance this equation in acid. So one thing you have to recognize is that anytime you see and you're asked to balance an oxidation reduction reaction or a redox reaction, and it's an acidic solution, there's two things that are plentiful that you will need to aid and assist in your balancing the equation. You'll have a lot of H plus and you'll have a lot of water. In fact, all of these reactions are occurring in the solvent of water. If it's in a basic solution like part D here, then there are two things that you will have to aid in balancing the equation. Is going to be OH minus and water, H2O. Obviously water is plentiful here. So here we have to deconvolute the reaction. So here we have Fe plus 2 going to Fe plus 3, that's one half reaction, and then we have H2O2 going to H2O, that's the other half reaction. So let's go ahead and balance this equation. We balance it with electrons after splitting or deconvoluting this reaction totally. So the way you go about doing this is you first have to realize that, okay, I have Fe plus 2 going to Fe plus 3. So that's one half reaction. We will balance the charge with electrons. It looks like the atoms are balanced because we have one Fe and one Fe on the product and reactant side. So to balance the charge, I'm going to add an electron here. So plus 3 minus 1 is plus 2, and we are charge balanced. By the way, if the electrons are on the product side, we call that an oxidation half reaction. So obviously H2O2 going to H2O is going to be a reduction half reaction. We also call that the anode when you're talking about a battery or electrochemistry. So we got our anode oxidation half reaction. The other half reaction is H2O2 going to water H2O. So this is going to be a little bit more complicated in terms of balancing the equation. The first thing you want to do is balance the oxygens. You notice here I have two oxygens here and one oxygen on the product side. So let's go ahead and put a 2 here. And now my oxygens are balanced, but my hydrogens are not balanced. So remember, this is occurring in acidic solution. So that's what we need to know in order to balance this specific half reaction. Since this is an acidic solution, I'm going to balance it with H plus. So I have 2 H's here. I got 4 H's on my product side. If I add 2 H plus here, 2 H's plus 2 H's is 4, and that will balance my atoms of hydrogens in my product side, which is 4. Now I will balance the charge. We can balance the charge using electrons E minus, and here I have 0 electrons, or 0 charge I should say. So to balance the 0 charge on my product side, I'll put minus 2 electrons here on my reactant side. So minus 2 plus 2 is 0, and I got a 0 here. By the way, if the electrons are on the reactant side, we call that a gain in electrons. And the gain in electrons, because remember, we're gaining 2 electrons, hydrogen ion is, H2O2 is gaining 2 electrons to become H2O. This is done in acid. So if the electrons are on the reactant side, it's a gain of electrons, and that's a reduction half reaction. And that's also called the cathode if you're talking about a battery. So now we'll balance this equation by canceling out the electrons. So no free electrons ever in your balanced chemical equation. So we'll multiply this side, the top half of the reaction, the oxidation half reaction, by 2. This will give us 2 Fe plus 2 going to 2 Fe plus 3 plus 2 E minus. Let's leave the bottom half reaction as is and write that out. We want to cancel our electrons at the end of this reaction. Remember, it's very important that there are no free electrons at the end of the problem. So the 2 electrons on this reactant side, cancel out with the 2 electrons on the product side, and now we will should have our balanced equation of 2Fe plus 2 plus 2H plus, this is an acid, so it's totally okay, plus H2O2 goes to 2Fe plus 3 plus 2H2O. Let's do one final check to make sure that we are totally and completely balanced. So 2 iron, okay, that's good. 2 hydrogens plus 2 hydrogen is 4 hydrogen. We got 4 hydrogens here. 2 oxygens and 2 oxygens. Now we got to balance the charge. 2 times 2 is 4. 4 plus 2 is 6. And 2 times 3 is 6. So we got a plus 6 here on the reactant side and a plus 6 here on the product side. We are charge balanced as well. So this is the right answer for part A.